Oof, I thought like I pressed go live button 2 minutes ago. Like, can anyone confirm if audio and everything is fine before we get started? And like, there were some issues with the mic, so do let me know if audio starts breaking in between. Like, I will try to switch stuff and try to see if it works. And like, before we get started, can anyone confirm if audio and everything is fine? And yeah, like, I ended up solving all the problems, and like, I was rank 1 after the contest. So thanks everyone. Hello, hello, hello. Can anyone confirm like +1 in the chat, or like, audio is fine or not before we start? Okay, looks fine. Thanks everyone. There would be a slight background noise, but like that was the trade-off I had for this contest. Yeah, so like let's get started. Let's go with the undated problems in D1 first. Chef wants to run at least 1,000 meters to reach his fitness goals. There is a rectangle park nearby with the length of X meters and a width of 5 meters. Can Chef complete his goal by running one loop around the park? Loop means running the entire path along the edges of the park. So like we first need to calculate like what is the length of the park around the boundary of the park, and then if it's at least 1,000 we should print yes, otherwise we should print no. And the perimeter of the rectangle or the path on the boundary of the rectangle is 2 times length plus 2 times breadth. So it would essentially be 2 times x plus 2 times y greater than equal to 1,000. Like the code looks pretty much like take two variables as input, then check 2 times x plus y is greater than equal to 1,000. If yes, print yes, otherwise print no. And essentially that was the solution for this problem. I will quickly go through the first three problems and then take questions on the first three problem if any. Money Double Chef Bank gives him a unique offer. At the end of the year, they offer Chef to add either 1,000 rupees to his bank account or double the amount stored in his bank account. Chef initially has X rupees in his account. What is the maximum amount Chef can accumulate after 5 years? And if we notice the constraint, like X is up to 1 to 5 and Y is up to 10. So one possible way to solve this problem is like we essentially brute force it and see like which method gives us the more money. Either we add 1,000 or we multiply it by 2 and we keep taking it until y times. And like that can be one solution for this problem. So like while for time equal to 1, time less than equal to y, time plus plus, what we can do is like we can assign x equal to max of either double the money or add 1,000 in the bank account. And at last we can print whatever x we have. This is one possible solution for this problem. One thing to notice here was like if we want to do more optimizations here, the other thing to notice here, like after we do x plus 1,000, like the value will always be 1,000 here. So like after the first step, like we would always do x into 2. So what we can do is like we can check for the first step, like if x is less than 1,000, like we only need to do x plus 1,000 on the very first year. So we can reduce the number of years, and after that we can keep multiplying by 2 among whatever the years have remained, and like that will also work over here. And there can be more, and like I think essentially this is enough to solve this problem. Rock paper scissors. Seth and Roku are locked in an epic rock paper scissors battle consists of n games. However, Seth has a secret weapon. He found a note revealing Roku's entire sequence of moves before it. You are given a string A where AI represents Roku's planned move in the AIth game. Each character of A is either RPS, denoting rock, paper, scissors respectively. Determine the maximum number of games Seth can win. He is not allowed to make same move twice consecutively. note that in like standard definition of stone paper scissors is given who beats who, and notice that it asks us to say that maximum number of times chef can win. It nowhere says that we should max, like if there are multiple ways to get 5 wins, then we should maximize the number of draws, or we should maximize the number of minimize the number of losses. Nothing like that. It essentially asks us count the number of maximum games chef can win. Nothing more, nothing less. And with the concern that we cannot make the same move 2 times. So like if we like, let's first solve for the case when all the elements are equal here. If we have rock 5 times, then the best we can get is 3 wins. Like we know that we will get a win when we play a paper, and Caesar gives us win. Caesar gives us makes us lose, and rock makes us draw the game. And the best we can get over here is like by making playing paper at the odd number of places. Okay, and here we have choice. We can do whatever we can make, either Caesar or rock, anything works. So the number of wins here like would be 3. In 5 matches we can win 3 times. And like let's say what happens if we have rock 3 times, 6 times. The best we can get is 3 wins, and that would be by playing paper 3 times. Like we can get 3 wins by playing paper 3 times. Like these would be the cases. And like the other cases, we can play Caesar or rock, whatever we want. We also have 2 choices here, Caesar or rock, whatever we want. So here, like if there is a need to play paper, then like we can do whatever we want. If there is a need to play Caesar here, then we can play rock here. And if there is a need to play rock here, we can play Caesar here. So what we can notice is that if Roku plays same move k times, then the number of wins we can get is k divided by 2, and take seal if required. And essentially now once we notice this observation, what we can do is we can count how many consecutive values are there in the same block, and then we can count the total number of wins. Or like the other way to do is like we can also notice like can we win in the previous move. If yes, then we have to skip the next move if the value is same. Otherwise we can take whatever we want. So essentially like the next problem reduces to take the original string, count how many consecutive blocks of equal characters are there, and then like do the seal by 2 part over there and solve the problem. Like we can probably maintain 2 pointer, but technically that's not required. But while as less than n, count the number of characters with same value. And like if count is odd, like we can do answer plus equal to count by 2 plus 1. Else we can do answer plus equal to count by 2. Or I think the default method of seal will also work. This should work. Like the numbers are not very large to have precision issues here. Like technically, like this seal method becomes a problem when the count becomes up to 1e9 or something. In the given constraints, like the numbers are up to 1e5, so this should essentially work fine. Any questions on the first 3 problems before we move to the other problems? Can you give answer for paper, scissor, scissor, paper? Like the answer should be 3, and the reason is paper, scissor, scissor. Like paper wins against scissor. And here like we can play paper and we can play rock. This will ensure 3 wins. Like we can decide first what all we should play for the winning moves, and then we can fill the alternative choice we have. Like because whenever we lose, like whenever we are not winning, we have two choices. Either like we win or we lose, and we can play any of them based on what is required here. Here like playing the lock will make us lose, and it's fine. Like it's possible to, it's allowed to lose because it's nowhere asking like we should reduce the number of losers, etc. Can you give a dry run for the third question? Like I'm assuming this is the same problem. Like I can share the sample outputs here. Like rock, paper, rock, 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 scissor. Like in this case, like for rock wins again scissor, right? Need to win against rock, we should play paper. So first move should be paper. To win again paper, we need scissor. Second move should be scissor. Third moves are two rocks. So we can play like let me just write it there. Like to win again rock, we need paper. To win again paper, we need scissor. To win again rock, we need paper. Here, like we definitely can't win. And to win again scissor, we need a rock, right? So like we here we can play scissor and we can lose the match here. And the answer would be 4 here. Similarly, if only one is there, we can play one move. And everything is rock, like it's the same case as we discussed about the answer should be 2. And like I will move to the rated for any problem questions on these 3 problems before I move to the other problems. Okay, I will move to origin. The origin of a positive integer is determined by iteratively summing its digits until only one digit remains. For example, to compute the origin of 1 to 9, we take the sum of digits of 1 to 9, which is 12. And because 12 is not a single digit number, we take sum of digits of 12 again, which we will get 3. So origin of 1 to 9 is 3. The problem asks given a positive integer and calculate the sum of origin values of integers from 1 to n. Like first thing to note here was like this is essentially digital root definition. Like digital root is defined the same way, repeated as natural number. Like it essentially says like keep summing up the numbers as long as number is not less than required value. And like there are some direct formulas as well, and that's essentially fine. The first thing to notice here was like when you start writing up the digital root sum, you will notice that the numbers occur in this sequence 1, 2, 3 up to 9. 3 up to 9. Like for example, the time value for 10 would be 1, value for 11 would be 1, value for 18 would be 9. And like the same cycle repeats here. 1 to 9, 1 to 9, 1 to 9. Or basically to summarize it directly, if we want to find like origin for n, if n percent 9 is 0, then the digital rule value becomes 1. Else the value becomes n mod 9, which is the case between 1 to 8. You can try to verify it using looking at all the lot of examples here, but essentially that is the solution for this problem. And once we know that the values repeat in sequence 1, 2, 3 up to 9, 1, 2, 3 up to 9, 1, 2, 3 up to 9, 1, 2, 3, like basically this dots denote all the values are there 4, 5, 6, 7, 8, 9. So what we can do is like we can look at the sequence of 1 to 9. This gives us sum of numbers 1 to 9. 10 to 18 will give us 1 to 9 again. 19 to 27 will again give us 1 to 9 bucket, and so on. Like there would be some buckets of 1 to 9, and there would be some sequence remaining outside the bucket, which would be essentially be n percent 9 numbers, whatever remains here. And like the number of such buckets would be n by 9. So like the answer would be for a full bucket, like sum of number 1, 2, 3 up to 9 is 45. So the answer is number of full buckets, take seal here, into 45 plus find sum of 1, 2 up to n% 9, which we can use some of the standard formulas we have, or like we can directly compute it, anything works. And like, essentially that is the answer for this problem. So like we count the number of full buckets, and like now for all the remaining numbers, t equal to 1, t less than equal to n, t plus plus. And essentially this is the solution for this problem. Any questions on this one? One second. Okay, I forgot to output my. Any questions on this one before we move to the next problem? And essentially this is the solution. And like now moving on to the next problem, 3 out, 1 in. Given an array B containing M, where M is odd integers, you have to perform the following operations on B until it consists of only a single element. Choose distinct integers I, J, K of array. Remove Bi, Bj, Bk from the array and append Bi plus Bj minus Bk to the B. Note that operation reduces the length of B by 1. For example, if B is this, we can choose index 3, 4, 5, delete these values and add a new integer 1 to it, containing 5 to 1. Your goal is to maximize the value of final element remaining in the array. Let this maximum value be f of b. You are given an array A of length and answer q queries to it. In the ith query, you are given an integer ki which is guaranteed to be odd. Output these values over here. That is compute the answer when considering only first ki elements of A. Each query is independent, so array remains unchanged across queries. So like essentially like one thing to notice here was let's first say that we have n elements, and among that it is possible to make multiply k elements by minus n. And like there can be different possible values when we are starting sequence of n elements. Like one thing which I ended up assuming here was like it like the value of negative numbers should always be floor of n by 2. Probably let's try to verify it. If we have only one number, and like that's the only positive number we have, and if we have a1, a2, a3, then after the first operation one of the numbers would be negative, 2 positive and 1 negative number. And similarly we can probably use indexation, or like we can continue verifying further. Like we have a1, a2, a3, a4, a5, and let's say in the first operation we have chosen some numbers. So after the first operation, like 4 numbers will have positive sign and 1 number will have negative sign. And after the second operation, so like we choose 2 numbers from here, like 2 numbers will definitely remain positive, and either we do a negative, like we take this as like the numbers would be a1, a2 and a bucket of a3 plus a4 minus a5. So now if we take this as a negative number, then overall we would get a1 plus a2 plus a5 minus a3 minus a4. And if we keep this as a positive sign here, then we can get like other possible choices: a1 a3 plus a4 minus a5 minus a2, or we can probably switch this a2 with 1 as well. Basically the TLDR was, my observation is like if we have 2k plus 1 numbers, at the end of the day k will be multiplied by minus 1, and k plus 1 numbers will be multiplied by plus 1 in the final summation term we have. And like we can probably play around with examples to find it, or probably we can use induction to prove it rigorously as well. Anything works. And like this is the crux of the operation. And like once we realize this, the idea is we will multiply the smallest k number with a minus 1 sign, and let the largest k plus 1 numbers with a plus sign. Basically, like we will know sum of all the elements. We will also try to find the sum of smallest k element and multiply it by 2 and try to get the solution. Like, can you please try using example? Yeah, I can do one thing. Let's say we have these 7 numbers. Like right now, let's not try to maximize the value, but rather see like how many elements we can have with a plus sign over here. Like if you look at the multiplication operation, it's equivalent to taking one element, multiplying it by minus 1 and keeping it in a fixed bucket with some other elements. So like for example, like if you choose these 3 elements in the first operation, the remaining numbers would be a1 plus a2 minus a3. This is one of the numbers. a4, a5, a6, a7. Let's say in the next turn, like you choose these 3 numbers, and like this is the one which gets subtracted here. So the remaining numbers you will have is a4, a5, a6 plus a7 minus a1 minus a2 plus a3. And now if you choose these as an operation, and let's say you have taken this as a negative sign, so overall numbers you would get is a5 plus a6 plus a7 plus a3 minus a1 minus a2 minus a4. So 4 numbers are there with plus sign and 3 numbers are there with the negative sign. And one thing you can prove is like if there are like let's say 19 numbers, then no matter how you apply operations, 9 number will have negative sign and 10 numbers will have positive sign. And essentially like this is the crux of this problem. And because we know that 9 numbers will have negative sign, the best we can do is like we can take the smallest 9 numbers, take some of them, and like we can store the value we have. So basically if the total sum is t, then sum of this and like the sum of negative numbers is n, then sum of positive numbers would be t minus n, and here like this is multiplied by minus sign here. So like sum of positive numbers, which is total sum minus sum of negative numbers, and sum of and overall we need is sum of positive numbers minus sum of negative numbers here. So this will end up becoming t into 2 times sum of negative numbers. And like for Sn we can say like, is this a intuition or past solve problem? I would say a mix of both. Like when you play around, like you will try to find some invariant here, and like that's then you can try to prove it like the invariant holds or something. And like once we realize this observation, like what we can do is like we can pre-compute answers for each possible value of k. K is odd, like we can try to find the answer for each odd k between 1 to n, and at last like we can directly print the queries whenever we need the final value. And like that is the idea. Like there are multiple ways to find like the smallest k values, and it has appeared quite some time. like you can try to use like there is one well-known algorithm median running median using two priority queues. So like one thing you can try to do is like you can notice that all the numbers which are multiplied by negative signs are less than a median. So one way to do is like you do like probably solve this lead code problem. You maintain the sum of heap along with the values in the heap. That is one possible way to do it. And like the other thing to note here was like we can only maintain like the smallest k numbers in a set as well. Or multi-set also works. Like I use two keys. And like the first value would be like whatever is the value of it. And like let's just use multi-set. And like this is the first value. Like we don't need the first value, or we probably need the first value in the set. Like when we have three numbers, one of them would be smallest one, right? Yeah, like we probably need two median over here. One of them doesn't work. What if the new value makes the operation in the new median value? We can't keep on sorting. Like we don't need to keep on sorting the value. Like as we increase to 2k plus 1, won't the smallest k values? Yes, smallest 2k values would change. Like basically the idea is, like let me share like the solution idea. Like the idea is we maintain two priority queues. One we call as small and other we call as large. Like the name value is different. Like this will contain smallest k values and this will contain larger k plus 1 values. And now like what the new thing we need is we have two numbers for insertion, a2k plus 2, a2k plus 3. We have to insert two new numbers in these queues such that now smaller queue contains k plus 1 smallest numbers and the larger queue contains k plus 2 smaller numbers. Like does this make sense? Before I go into the implementation detail of how we get this updated to priority queues or whatever sets we want. Like initially let's say like in starting we can say k equal to 1, which we will put one element in the set. Now we have to put two new elements in the set such that the smaller one contains one extra element and the larger one contains one large element. So first thing we can do is like this has k element, this has k plus 1 element. We have two values up for insertion, a2k plus 2, a2k plus 3. So like we can like one thing we can notice is that the largest value here if sorted here and smallest value here like this would be greater than equal to this. So first we can do like we can arbitrarily insert like if this value is greater than this, Like if AK is like this is the largest value we have in the smallest set, let's say. If A2K plus 2 is greater than equal to large, insert this value into large Q. Otherwise, insert this value into the smaller Q. And similarly, we can do for A2K plus 2 as well. So after this is done, this would be the smaller Q and this would be the larger Q. And the size of this Q can be between K to K plus 2. Like any possible size is there. Based on where we have inserted values here. And here the size of Q can be K plus 1 to up to K plus 3. Based on like where we have inserted the new two values. The idea is like, first let's ignore the size constraint we have. Just insert them into the correct Qs. So we have some set of smaller Q where the largest value would be less than or equal to smallest value in the larger Q. Now we have two elements to insert. If the new element is less than like the largest element in the smaller Q, insert it into the smaller one. Otherwise, insert it into the larger one. And now we can do is correction. Now we can run correction algorithm. As long as size of smaller is greater than K plus 1, as long as there are X element, pop largest element in smaller priority queue and push it into larger queue. So the idea is all the X element which are there, move it from here to move it here. How many X element we need? Or like the case can either be like the number of sizes larger than is less than K plus 1. In that case, we take the smallest element from larger and push it into smaller set. So like the idea is like first we put elements so that the sets remain sorted, and now we move the boundary elements here to make whatever required size we have. And like now if I look at the insertion, like I have one insert operation, like I have one value v which keeps the sum of all the elements in positive set and minus multiplied by the sum of elements in the negative set. Now when I am inserting a new element, like I am using a pair, like essentially let's just assume all the elements are distinct. And instead of priority queue, I am mostly using the set so that getting the smallest and largest values is easy. You can also use multi-set. Otherwise, you will need one min priority queue and one max priority queue. And essentially that's not ideal. So if the elements from the positive set are empty, or like the positive smallest element in the positive element is larger than or equal to whatever element we want to insert that element into positive set, increase the value by plus whatever like value here, because my value is sum of elements in positive set minus sum of elements in the negative set. Otherwise, like if this is not the case, then we should insert element into the negative set. These are the insert operation. At first we need to insert the 0th index, then we need to insert element in the pairs, two elements here. And then I have one correction like update size as well. This will ensure like whatever size I want is the number of size for the positive element. So after the first element, like there should be one positive element. And as we keep increasing, like the number of positive element keeps increasing by 1. And to fix size, like let's call it fixed size. And now it moves boundary. If the number of positive elements we want is less than required size, we find the largest element from in the negative set. We remove it from the negative set, we insert into the positive set. And while the largest element, like if the size of positive elements is greater than required, we remove the smallest element and we push it into the largest element. Along with that, we update the value to required value, maintain sum we have. And essentially like that is the idea for this problem. And like this is the correction algorithm. Why do we need two priority queues? We are only checking with smaller PQ, right? Okay, the problem here is like I also thought of coding this and I realized the mistake here. Like we have this as the element 1, 2, 3, 4, 5, 100, 200. So when we are among these elements, the smallest queue would be 1, 2, 3. And if we do not keep a track of it, we will end up inserting 100 here. But we should insert 4 here. And that is why we need all the elements here. Any questions on this one before we move to the next problem? So like I have pretty much used a well-known trick to make all the elements distinct. Like ideally you can use multiset or you can use a pair of elements where the first value is the required value and the second value is the index. So if you notice the value I am inserting is the first element is the value, second is the index, and all the indexes are distinct. So set works. Or like if you want to make it LLI, then you should use a multiset, and like there would be some nuances when erasing and inserting element. Okay, one example test case. Like let's take the sample as well. The sample is 3 minus 1 2 4 5. Like for the first test case, like we only have one value. So smaller set would be empty and the larger set would be 3. And like if we look at sum of elements in the larger set subtracted from the smaller set, the value is 3 here. So the answer is 3 for this case. Now we have two more values, minus 1 and minus 2. And you will notice that the updated value looks like this. Like we need one value in the smaller set, that can be minus 1. And we need two values in the larger set, which would be 2 and 3. When we are taking these three elements. And you can notice the sum of these elements is 5, sum of these elements is minus 1. So overall our answer is minus 1, which is 6. So answer for this case is 6. And now we have two more elements, 4 and 5. And you can notice like now the boundary will shift like this. Which is minus 1, 2. And larger element here would be 3, 4, 5. Sum of elements here would be 12. Sum of elements here would be 1. So 12 minus 1, which is minus 11 here. And like this is the answer for the third test case. And now like juggling around would be like and I will probably move to the next problem now. Like for code, like I would upload my screencast where I have coded all the problems. You can probably look at it once. A prison is represented as a n cross m grid consists of zeros and ones, where 0 denotes a prisoner and 1 denotes a guard. In one move, a prisoner can move one step left, right, up, down. Formally, the cell XYZ prisoner can move through these four cells. A prisoner can escape if he reaches outside the prison. Formally, he reaches cell X, any X cell XY such that X equal to 0, Y equal to 0, X greater than N or Y greater than N. Let the escape time for a prison be minimum number of guards he needs to cross before he is able to escape the prison. What is the maximum escape time for any prison? So like what it has been given to us is Like we have a grid. Like let's take the first sample itself. It says we have a 3x3 grid. Here, like there is a prisoner, and at all the places we have guards. And if prisoner reaches this area, then he will be set free. And no matter how he wants to go from here, he will at least have one prisoner over here. Like he can also take this route where he would encounter two prisoners, but it's not ideal, right? Taking two from here is better than going via this route with one or via this route with one. And like that's the only time, and so the answer for this case is one. Like let's take one more example. Like in the second example, you can notice like all the prisoners can go using these zeros and no more route is required. Third test case is a bit more complicated. Like we now have a 5x5 grid. Like we have, I will mostly denote prisoners here. Like we have 5 prisoners here. And at all the places there are guards. So like if this prisoner wants to move out, he can take this route. He will encounter one guard and he can get away with it. Like any other route will take at least two more people. Similarly here only one guard is required. But if you notice this person, he will always encounter two guards here. Or if he takes this route. Like any route he takes, there would be at least two guards there. So like the answer would be maximum time any of the prisoner takes. So like the answer is 2 here. And like as someone mentioned, DFS for this gave a TLE. Like what we essentially need is like we can look at it the other way around problem here. Like if we look at one prisoner, we do a DFS trying to find like let's first look at what DFS we need here. So like there is a position here and the next cell can either be a prisoner or next cell can either be a guard. What we say is like if we go to the next cell to the next prisoner place, we say like there is an edge with cost 0. And if next place takes us to a guard, we say that the edge cost is 1. So now you see like whenever you land on a cell with guard, we say that the cost to jump on that cell is 1. And if you land on a prisoner cell, the cost to land on that cell is 0. So now if you look at it, the problem like this, then for any prisoner to move out of the cell, the minimum number of guards he would encounter can be said as the shortest path from that cell to the outside boundary. Yeah, any questions on this one before we discuss how to optimize it further? Like obviously like taking any cell and moving to the further one would not be the ideal scenario. So like we can look at it the problem other way around. We have this grid. We have some outside cells. Instead of saying like asking how much guards one has to pass through, let's count for each prisoner how many guards one has to pass through if one wants to come and meet him in the prison. Instead of going out, let's say someone from outside wants to meet someone. Like the problem is equivalent whether you go out using a smallest part or whether you come in from outside. The number of guards you will meet would always be the same. Once we look problem at it like this, now we can use something known as multi-source Dijkstra. Like 01 BFS is the other term, but that's not required. Multi-source BFS, Dijkstra, whatever you want. Like the idea is, instead of putting only one person in the cell with the starting in Dijkstra, we put first node in the cell with distance 0, and then we continue running the Dijkstra, right? Instead of doing that bit, what we will do is like we will insert all of these person in our Dijkstra queue with distance 0. And then the rest of the code, like the only difference is when we are starting, instead of putting one node in the Dijkstra queue at distance 0, we would put all the nodes which are outside boundary at distance 0. And the rest of the code is same as the original Dijkstra. And once we are done with this, we would have for each node the distance it needs to come from outside. And we can look at the maximum value of that distance and print that distance. And essentially that is the solution for this problem. Like there are two ways to solve this problem. Either we can insert one node into the Dijkstra, and like for each node outside we run multiple Dijkstras and try to find multiple minimum whatever we want. Or the other way was the similar. So like now I have a Dijkstra code. Like this is the function which pushes node into the queue, which takes two cell x and y. Like first what I have done is I have added boundary in the cell by making n plus 2 and m plus 2. So like the 0 index consists of all the zeros, n plus 1 index consists of all the zeros, and everything over there. And in case n plus m by 2. Now I have a distance variable similar to Dijkstra for each node. What is the minimum distance required? We can use the 2D distance as well, but that's strictly not required. Now I have push value like push node into the Dijkstra queue. Instead of priority queue, I am again using a set here. That's fine. If it's outside the grid, we can now ignore it, doing n plus 2 each of the time. Otherwise, like I have this, like instead of 2D vector, I was using 1D vector. So like some encoding is there. And like now the idea is like we are jumping to x comma y, and the current number of guards we have encountered is t. So that based on cost, if this is a guard cell, then we have encountered one more guard, so we should add it to the cost. If distance to reach this node is less than equal to nt, we don't have to push it into the queue. Otherwise we may have to erase it from the set, or it's priority queue, you can probably ignore it as well. Like it's exactly same as the Dijkstra. Like the way I code Dijkstra is different from the way you code, so that might be the difference. Otherwise update the distance and insert like this value again into the queue. So in starting, I am adding all the elements at the boundary in the priority queue for the Dijkstra, which are at distance 0. And I also maintain answer like the maximum distance I have encountered. I pop the smallest value from the priority queue, erase it from the priority queue, look at what the coordinates are, and if it's the prisoner cell, I should update it with the max value I have. Because we don't have to count the maximum number of guards to encounter there. And for each neighbor cell of the current cell, update the distance again. And like these are the 4 directions I have. And like essentially that is the solution for this problem. Any questions on this one? Like overall the time complexity would be n into m into a log factor. And like there is something known as 01 BFS. You can take it as an homework exercise. And using which you can remove the log factor here. It is also possible to solve it into time complexity of order n into m. But the XR constraints did allow the XR log factor because sum was up to n into 1e5. Any questions on this one before we move to the next problem? Okay, in last 6 minutes, 42 submission happened in this question, like probably cheaters. Like BSR, like CodeChef does run MOS, and like they try to catch like similar codes over there. So like I'm hopeful that most of, if those people are cheated, most of them would be disqualified after the contest. Like there is a blog here. Like you can probably search for plagiarism here. Like there would be a blog. Use this blog to report anything related to plagiarism. And like after the contest, like CodeChef also says the number of people they have disqualified in the contest. Yes, this is the blog. So you can probably give your shot. Like here, they also say stats. So like, and I would say probably focus on yourself, because like anyone, if someone copies from you, they may get better rank in the contest, but in the long run, that's not possible to get whatever results they want. Like and like as far as rating is concerned, like anyone who wants to judge you, like he will definitely ask you question rather than blindly looking at rank and whatever their purpose is there. So this was the idea. Like probably I will move to the next problem then. Any questions on these three problems before we move to the next problem? Like, but if k equal to 3, we only consider first three element. Like I am considering first three elements and adding two more elements in the set to process. It was for the previous one. Distinct, I think I have already clear. Why do we need two priority queue? I think I have answered it. When do you update priority queue if new value made is smaller than minimum value? Where do you, I think is the question. Like the idea is like look at the largest element and smaller. If current inserted element is less than it, put it into the smaller queue, otherwise put it into the larger queue. That should be fine. The main constraint is like the smaller, largest value in smaller set should be less than equal to smallest value in the larger set, so that the ordering remains same. The sizes gets impacted, but we can fix it later. So any questions on these problems before we move to the next problem? So the problem is count good RBS. It says a string of length m where m is greater than equal to 2 contains only opening and closing bracket is called good if it satisfied following relation. X is a regular bracket sequence, and if you remove the first and last element, the remaining part is also a regular bracket sequence, where XLR is known as the substring of X from L to R. And like once we are done with this, like we are given some examples of good string. Like this is a good string because if we remove first and last character, the remaining part is an empty string. So that by definition is good. Is a regular bracket sequence. Like basically the regular bracket sequence is defined as we have initially empty sequence, and if basically like there for each opening bracket there would be some matching bracket at the end, and like that is essentially the definition of regular bracket sequence. Or other way to look at it is like if we is it possible to insert some plus sign and some numbers in between each bracket so that it's a regular, it's a correct mathematical expression. And like it's a bit of standard definition here. The only part about the good sequence was it should be a regular bracket sequence, and if you remove first and last element as well, then the remaining part should also be a good bracket sequence. So for example, like there are some examples like this is a regular bracket sequence because for every starting bracket there is a closing bracket. Like for first second character is there, for third fourth character is there. But this is not a regular good sequence because if you remove the first element and the last element, whatever remains is not a regular bracket sequence here. And like there a lot of definitions are there, and it asks us to count the number of sequences where I is less than j and k is less than l, such that both the substrings are equal and I to j is a good sequence there. And like once we try to simplify and see what it's happening, like the problem simplifies to like one thing is like we define a Euler tour of a, like we let's say we try to create a graph where if there is an opening bracket we will move to child, and if there is a closing bracket we will move to parent. So for example, let's take some string. Let's take this as an example. And like moving by child means we create a new child. 1 2 3 1 2 1 2 1 2 3. So we have some root node. Now there is an opening bracket. So we move to one of the child here. There is an opening bracket again. So we move to one of the child again. There is an opening bracket again. We create a new node and move to it. Now there is a closing bracket. So we move to parent back. There is a closing bracket again. So we move back to parent again. We are here now. Now there is an opening bracket. So we create a new child and move to that child again. There is an opening bracket again. So we create a new child and we move to that child again. Now we move up. Closing bracket, let's move up. Closing bracket, let's move up. And closing bracket, let's move up. So you will notice, like, if you follow this process, once you start with the root, you will end back at the root again. Because basically the number of opening brackets are same as number of closing bracket. And for each closing bracket, there would be a bracket before it as the opening bracket. And the next part to notice here was, like, if we look at each node as a sequence of nodes from L to R, which corresponds to this string. Like, for example, this tour of nodes is given by this string. Or if we look at, like, if we look at this tour of nodes, like, this is given by these nodes. And like, if you try to look at it more, you will see, like, each subtree is a regular bracket sequence. Because the idea is, like, you move down only when you encounter an opening bracket, and you move up only when you encounter a closing bracket. So if you start from a node, move to some nodes in the children and come back to it, then for whenever you move down, you add one closing bracket to move up as well. And because you did not move past the parent, so like there was always a valid node. And like, this definition is critical. Like, the difference between regular bracket and good sequence was when you remove first and last element as well, whatever remains is a regular bracket sequence as well. And basically, if you look at each subtree, let's say we have one more sequence here. Like, this would correspond to one open, open, close, open, close, open. Wait 1 second. Let's pick this as an example. Let's move back. Make it open. Like, let's say this is a sequence. For the topmost, it like this complete is a sequence. Like, this is the original root we have. So for this node, like, the bracket sequence we have is this. And like, for this node, you will see, like, these two brackets are there. And for this, you will see these two brackets are there. And this string here is a regular bracket sequence which consists of only taking children's here, but it's not a good sequence. So basically playing around here, you will boil down to, in this graph, each node, subtree of the node will correspond to a good sequence. While if you take multiple child, not the parent, that would be a regular bracket sequence, concatenate them, but it will not be a good sequence here. And the idea is like now we should count the number of subtrees which are exactly identical to the other subtree over here. Or probably the other way is like we can use small to large technique. And subtree string hairs. Like we can use subtree string hairs to get all the good sequences, and essentially like that is the idea we have for this problem. So like we can essentially count the hairs of all the good sequences, and then we can count the value we have, and we can use small to large. Like the way I have implemented is slightly non-trivial. Like probably like it would be better if you can refer someone else code. Like the idea was to get all the string hashes. Like I tried to do it using prefix sum idea over there, but essentially like okay, like some of the test cases fail. So what we can do is like whenever we are merging nodes, we can take the other count pair equal here, and essentially that is the idea. Like probably I won't deep dive into code here, but that's the idea. Any questions on this one? Like what I needed was one string hashing, which I copied from the character template I had. And like now this has interval, if you pass on to L2R, it gives me the hash of interval from A to L. And then I implicitly created this graph. My implementation is slightly non-trivial where I am using some prefix sums over here. But you can get it in a better way by running a loop and moving to the child, or basically recursively going for the other node. And any questions or anything on this one before we move to the next problem? Like this is on YouTube. Will you put this on YouTube? Like this is on YouTube, and I will keep this stream public only. And like that was the main idea for this problem. Any questions on this one before we move to the next problem? Okay, I will move to the next problem. Like Ceph as a tree with n vertex, vertex I corresponds to AI, and like there are two types of queries. Either change the value of some vertex, or like we are given two nodes, we should look at all the values on path from U to V, and then we should find the minimum possible value of this expression. Like this expression does not help us at all. And like let's see what does this expression means. So let's say we have two numbers AI, AJ, and like there are some bits over here 0, 1, 2, 3, 4. And let's also look at AI into AJ here. If let's say this bit is 0 for this number, 1 for this number, then the AND would be 0 here. So overall we would be left with is 2 to the power I by 3 in the complete part. Like the contribution due to this would be overall, like in the sum it would add AI plus AJ by 2 minus AI and AJ. If one of the bit is 0, like if one of the bit is 0, then overall like it would add like 2 to the power 3 by 2 on this side and nothing on this side. While let's say if you have both the bits 1, so and will also be 1, and what you can see is like in the sum it would add 2 to the power 4 plus 2 to the power 4 by 2, and in and also like it would be 2 to the power 4, and overall you can see like this will cancel out. So overall if for ith bit both the numbers are 0, overall contribution is 0. Both the numbers are 1, overall contribution is 1. If any one of them is 1, then their contribution would be 2 to the power I by 2, 2 to the power I by 2. So like then if we try to simplify it, our expression will become AI plus AJ by 2 minus AI and AJ. It turns out that this expression is AI XOR AJ by 2. And this is mostly manipulating over here. Like you see like this part is XOR only, which is essentially divided by 2. We can say it adds 0 by 2, it adds 0 by 2. And like there are other ways to look at it. Like one can simply say like look at this identity and try to manipulate it. Like essentially that was done in the editorial. And like now what we need is like we can remove the smallest bit. And taking XOR and then divide by 2 is essentially removing the last bit, right? So either you take XOR first and then you remove the last bit, or you remove the last bit first and then take XOR. So this is also equivalent to AJ by 2. So what we will do is like we will divide all the numbers by 2 first. And what we essentially need is like the minimum possible value of XOR on the shortest path from U to V. And like that is what this expression boils down to. Any two elements in path. Like any questions on this one? Like any questions on this observation first before we try to go for the next one? Like I am a big fan of you, but I don't like to see solution for the problems. Like there are two bits. If my explanation is not good, then I can try to improve, and like there are more people, you can search it on YouTube, so you can refer them. But and if you say like you just don't want to look at solution, then I strictly advise against it. You should definitely look at solutions of the problems you cannot solve it and try to solve it later in the contest. And like that's the only way you would improve. So you should definitely look at solutions of the problem. Yeah, like I'm not saying it's me, but if the answer is you don't want to look at solutions, then you should definitely do that. And you should change it if you want to improve it. So now coming back to the problem, it says like we want the minimum possible value of XOR. Like the next critical part was notice that the all AI and X are up to 2000. So when you divide by something, the values would be up to 1000 only. And like the other critical observation is like XOR of two same number is 0. X XOR X is 0. and we have 1000 distinct values, 1001 distinct values. So the crux is, if the length of part from U to V is, let's say, 1002, then there would be at least two same numbers. So in that case, like the minimum possible value would be 0, so print 0. If the distance from U to V is at least 1001, you directly print 0. You don't have to do anything. Otherwise, what you can do is, you can go to each number and try to count how many times each number appears. Like you can maintain an array of 1 to 1000, and you can go through, you can find the LCA first, and then you can jump onto from U to LCA and V to LCA, and for each element how many times it appears. Like some of them can appear 2 times, 0 times, 1 times, etc. Like for each number, just count how many times it appears on this part. And like if any number appears greater than or equal to 2 times, print 0. Otherwise, we can say that all the numbers appear only once. So the critical idea is, like we have some numbers, all the numbers appears only once. Like let's say A1 is greater than, A2 is greater than, A3 is greater than, A4. Like we can also, like because we know the count of each element, we can iterate from 0 to 1000 to list down all the numbers. The critical observation here is, like the minimum possible value is, we only have to take XOR of only consecutive numbers here. And essentially that is the idea for this problem. Like although there can be, if there are k such numbers, there are around k square pairs, but we don't have to look at all the pairs, we can only look at adjacent pair. So we will look at most k minus 1 pairs, and like that is the solution we will have. Like some things needs to be simplified, while looking at only adjacent elements is enough. And like the other critical part would be, like if the length is more than 1001, why there would be at least two elements with the same values, and why we can directly print 0. So like that would probably be left as an exercise for the viewers. So now looking back to the code, what I have used is, I have used template library to find the lowest common ancestor over there. Like I would, and then I also counted the distance from any two nodes here, and like I have pre-calculated the parents so that I can directly jump on the parents there. U to V, if there is an update query, divide the value by 2, add change AU to V. Otherwise, we have from U to V. If distance from U to V is greater than max, which I have defined as 1023, that's fine. Directly print 0 and move on. Otherwise, I have this frequency table of size 1023. And because now if I iterate on all the elements from the path, number of elements I would encounter is less than 1023. So I add the value at LCA to this frequency table. From U, I move up to LCA, computing each value. From V, I move up to LCA, computing each value. And running path is similar. As long as we have not reached the LCA, add the current value. If frequency is greater than or equal to 2, we don't need more values. Answer is definitely 0. Otherwise, keep moving up to the parent here. So when I am done moving it, frequency table contains count of all the elements, which how many times it appears in the set. If any element appears more than 2 times, output directly 0. Otherwise, whenever like we need the only consecutive pairs here. So I am maintaining this PVR vector, like what was the last non-zero value here. So if this is not equal to 0, take XOR with it and assign it the current value and print whatever answer we have got. And essentially, like that was the solution for this problem. Any questions on this one? What extension you use in Sublime Text for CP? Like I can say it at the end of the chat once I'm done with the last problem. Like template from Cactal are better or AddCoder are better? Like my preference is I use AddCoder first, and if something does not exist in AddCoder, then I go for Cactal. Like finding the LCA is definitely not there in the AddCoder library. It's not here. Like last problem is permutation cycle queries. So like you are given an array A of length n and a permutation P of integers from 1 to n. Let P f of P comma I denote the sum of minimum values of AI within each cycle for of set of permutation cycles of P. A lot of definitions are there. A permutation cycle is a cycle in a permutation graph where each node represents index from 1 to n and there is an edge connecting from I to Pi. And P, if P is a permutation, each connected component is a cycle. Some examples are given to us. Like for example, if our permutation is 2, 4, 1, 5, 1, 3, then from we have an edge from 1 to 2. We have an edge from 2 to 4. We have an edge from 3 to 5. We have an edge from 4 to 1. And we have an edge from 3 to 5. And if you look at this graphs, every connected component is a cycle now. What it says is like now given values of A, find the minimum value at each node. So we need minimum of A1, A2, A4 plus minimum of A3, comma A5. And like now if you look at the given set, like these values are respectively 1 and 5. So for this value the function becomes 6. And what it says is like the g of A is defined as sum of values of f of P comma I for all the possible P and factorial permutations of P. So like this is just one example of permutations. If there are n elements, there are n factorial different permutations. And then there are some queries. Let's forget the queries first. Let's see how do we compute f of A for the given values of A. So what I did was I wrote a brute force code which generates all n factorial permutations. And like let's say the sorted array is b1 up to b2 up to b3 up to bn. So I counted the coefficient multiplying factor for each element. Like for smallest element there would be some multiplying factor f1 when you look at sum for all the elements. For second smallest there would be f2, for third smallest up to, and for the smallest element there would be some fn. And for overall like the answer would become fn bn plus f2 b2 plus f3 b3 and so on plus fn bn. Like the idea was write a brute force like which runs for n up to 8 only, and like for each element in the sorted sequence find the multiplying factor we need for the final element of the cycle. So which problem is it? So like essentially this is my code where I am running for n up to 8. For each n create all the permutation, you can use next permutation function and a boolean function like for each cycle how many times, if j is the small j, for j smallest element how many times it will occur, and at last print it for all the possible permutation. And the next thing I did was I just added these numbers directly on the OES here. It's a website where you can look out for if you have some sequence of numbers, you can try to find a general formula for it. And it directly gave me like for the kth smallest element multiplying factor is n factorial by k. Kth term on the intro product from all to n except k and tk is n factorial. Like there are two sequences, but that and like this essentially gave me like multiplying factor fi would be n factorial by I. So like for ith smallest element, we should multiply it by this number and overall get the sum for each possible values of it. At this point, I did not bother proving like why this should be the multiplying factor. I directly used it. And like once we know this, like now a brute force way would be you replace AI with X, you sort all the elements of AI, and you calculate this value and print it. Like that would be a brute force solution over here. And one nitty gritty here was like we have to calculate it for M. M is different for each value, and it's not necessary that M is a prime. But let's deal with it later. Let's say we have some ways to find this value for the given mod M, whatever composite prime one, whatever is given to us. So brute force way is to we can take B equal to A, we can send BI equal to X, sort all the elements of BI, and we can get whatever we want. That is one way to do it. Another way is like because like queries are not maintained for the next values, what we can do is like we can, if you notice the initial element, there would be like this is the sorted order. Like originally AI would be somewhere here, and when you change AI to X, either this AI can jump in the sequence here, or this AI can jump in some element sequence here, or AI can remain here. And the order of all the elements will remain same. So the idea is like if this was the original sequence, here was AI and X is also here, then we can directly look at the multiply. Like we can first calculate the initial answer, which would be for given permutation A. And now we calculate the difference when we jump one element around. If the sequence is like this, then we can remove AI into Fi. Let's say OG as original answer. Like whatever multiplying factor is there. Like OG as the original answer. Minus multiplying factor of AI. Plus the same multiplying factor of X. If the sequence jump is like this, here was AI, and like these are the elements smaller than AI, and these are the elements. And if the sequence jump is insertion here, then you can see like the new sequence looks like this. This X, these elements here, and this elements here. Like let's say like we have A, B, C, D here, E, F, G, H. Then the original sequence, new sequence becomes E, F, A, B, C, D, G, H. And like it's essentially like we remove the contribution of AI from here, we add X back, similar to what we did here. And we need like what is the updated contribution when each element in this sequence gets shifted to right side once. And like that we can probably use a prefix sum technique to get like for AI for range of numbers from L to R, what is the new contribution if we shift it to the right ones based on what our original sequence was. Or if our sequence is like this, AI is here, some set over here, and like this is the place where X gets inserted. Like then also we can notice like this would look like this. Like this new sequence becomes A, B, C, D, E, F, G, H. Now here like each element is shifted to left side once. So we can use like similar technique like for elements from L to R. If we shift each of them to left, what would be the updated contribution? And like that's what we need. And because and we also need n factorial by I, and we don't have like the I inverse for the given mod. What we can do is like we can maintain one pref function I, which is sum of first I elements, and we also maintain sub I, which would be all the elements up to I, product of from n to I. So what we need for Fi is product of all the elements 1 up to I minus 1, and product of all the elements I plus 1 to n. So which can be ref I minus 1 into suffix of I plus 1. And like that can be the idea, because like we need product of everything excluding one element. We can first find the sum of first I minus 1 elements, and then we can also find sum of from all the elements from n to I plus 1. And like that way we don't really need the inverse here. And like essentially like these are the ideas for this problem. Some add corollary libraries there. First pref function, which is I factorial, then sub function which takes compute. And for Fi, what I did was for the k smallest element, like sum of k minus 1 element and sum of from k plus 1 to n, I take original array A. Like similarly, like as I did the last time, because elements are not distinct, to make it distinct, I added one index over there so that now I can assume all the elements are distinct. Sort all of them. Find the default value of answer or OG answer, where like for bk smallest element, this is the multiplying factor. Now for each element, if we shift it to the left or shift it to the right, what would be delta cost? So for like kth element, if we shift it to the right, if we shift it to the left, earlier multiplying factor was fk, now multiplying factor is fk minus 1. So that's the delta we have. And now if we take the prefix sum on this part, you can, for L to R, like you can take the difference from R minus L to get what would be the required delta if you shift everything from L to R. Similarly, we can also calculate the cost for shift right as well, because if you move from kth element to make it k plus 1 element, you should subtract this code and you should add this code. And essentially this is the idea. Now to answer the queries, we have default answer. We can also find for a given range, if we shift them to the left once or shift them to the right once, what would be the delta we need. If given value is same as the original value, just print default value. Otherwise, find the place of old index and find the place of new index in the original list as well. If both of them are same, take default answer, take multiplying factor of that place and do the difference between them. Otherwise, if insertion is before here, like one thing to notice here is like when you remove the smaller value, the value from right gets plugged in. And like this would essentially be the value for the right. Remove the contribution of old index, add contribution for the new index, and you shift everything in this range towards left. So add that contribution, print the answer. Similarly, if the new value is inserted before the right value, similar thing, find the new two indexes, add contribution, add update contribution for both of them, and now shift elements to the right side. And essentially like this was the code for this problem. And like I think with this I am done with all the solutions for this problem. The critical part was, why is this n factorial by k? Like I just looked at, found a pattern, and I went ahead with it. I believe editorial will contain a proof for it, and although the editorial was not out by the time I started this stream, and like that is the hardest part for this problem, and we went ahead with it without, yeah, editorial is out. Here like it says n factorial, and like there is a proof for it, so you can refer it here. So any questions related to any problem or any other in general question before we call it a day today? What extension you use for Sublime Text for CP? Yeah, I can paste these links in the chat, and I am basically use Eknerwala's setup. Like just give me a minute, I will fetch it. Like these are the two links that I have probably used to set up the code here. One is a make file, like Ekner wala, and like other is using other is like parsing the samples from the problem statements. Along with that, I am using this competitive companion extension. So this extension and then these two scripts I am using to pass all the samples locally and run it in one go. Like there are different people have different extensions. You can like probably look at Abhishek Saini's video on it or Utkarsh Gupta's video on their competitive programming setup, and that should also work. Do you work as a coach? No. Like presently, this YouTube is the only place where I try to teach some stuff. And like apart from YouTube, I work as a software engineer, so like I don't have enough time to do the other things. How would you rate today's contest? I could only solve up to prisoner's problem. Like if you ask me the rating of the problem, then I think it's quite balanced. But if you want a feedback on specific problem, I would end up saying like the ideas were not a bit new. Like I have seen those ideas before or tried those ideas before. It was for me mostly putting in those pieces of the ideas which I already knew to make the complete solution for a problem and solve this problem. So like even in the permutation cycle, like once I found the idea using brute force, like I knew what to do there. Ceph and Bittree, like I have seen similar problems before where pigeonhole principle is the name. Like if you have 1001 distinct values and if you have 1002 values, then two values must repeat. Count good RBS, I would say I am surprised by looking at 61 submissions here. And like was definitely not expecting like a lot of people would get the insight of how the graph traversal and all works there. So and like this one looks a bit inflated. Either people were smart or like whatever be the case. Like prison escape, like I think if you knew 01 DFS or multi-source diagram, you would have heard the term of it. You should be able to solve it. 3 out, 1 in, like getting the idea was a bit tricky here. Like how many should be negative, positive, and then realizing this is always possible. But apart from that, once you get it, it's done. OG, I would say, is a standard digital root problem. How do you calculate sum of digital root? In fact, I have created problems before trying to do the same thing with a more harder version for the problem in this contest. And like these three problems, I would say mostly for people to start the contest over there. Some if else are mostly there. And yeah, that was it. I am visiting the first time on this channel, trying to digest things and trying to understand. Like you can put out the comment if something is not clear, or you can also refer to the official CodeChef solution as well. Like if you search the problem name here, like you would get the solutions here. Like there are like for example 3 out 3 in would be here, or you can search it with tag start 134. Looks like 3 out 3 in is not there yet, but it would be there sometime soon. So like the tricky part about 3 out 3 in is like there is no topic, or probably for the topic you would need running median idea. You can refer to this lead code problem over here. So you can try to solve this problem for 3 out 3. Like the code required is essentially same as this problem. But the main idea for this problem was to realize why we need the sum of smaller k element and not the larger k element. So like the piece, like the main critical piece for 300 is realizing we have to take sum of plus k plus 1 first k plus 1 element and subtract it from the smallest k element. And once you realize this, the remaining part of the code is probably something which you will find a lot of YouTube videos on. So what kind of like it's mostly web development. Like I worked a bit on front end side and some on back end side as well. and probably I would focus for the upcoming year session. Yeah, because it's not mentioned on LinkedIn because like I was trying to put in my the company where I work at there, and the mostly the reason is I am not representing them here. And like, so please post it every week. Like I try to post as much as I can, but like every contest is physically not possible for me. So new subscriber respect for the grant editing. Thank you, Aaron. And yeah, sir, how so strong? Like the only answer I have to say is it's with practice. Like for me to get the first contest win, which is dating up to like the contest I created was 6 years ago. And if you look at CodeChef, you see it's 6.5 years ago. So like it's not at all easy. And like probably if you are looking for some advice on how to improve or something, you can probably look at my Discord server where I have created a channel. The channel name is mostly a clickbait. Like where is it? Roadmap to red. Yeah, roadmap to red in 2 minutes. Where I have mostly said like what is my first tip, starting tip for the beginners, and like if they want to learn some standard topics say deeply, then what are the resources they can refer to, and what I was actually doing when I was below expert, when like when I was targeting for the master rating, like, and like there are different parts to it. Like this is some short crisp 5 to 10 messages where I have tried to explain like what is my philosophy when you want to start learning. And essentially that is, can you teach something like DP graph? Like the idea for the channel is to eventually have the videos on it, but for right now like these post contest discussion stream ends up taking all of my time. So like what I try to do is like, okay, I am also a working software engineer. Is there any bit of doing contests regularly for switching company? Like if you personally ask me, like these contests mostly are not beneficial because I end up solving it. So if I want to switch, like I would probably, there is a good probability I will already solve it without solving these contests now. And mostly I'm doing this contest because like I just started this channel and I want to see if I can teach people. While if you are unable to solve a lot of problems, then definitely there is a benefit where like for the companies which ask competitive programming problems, you will have an edge there. Like that is there. Is it's better to write a CF blog than Discord as it's difficult to use. Like if you search for CF, like every month someone writes a blog on this. So like I'm not adding a value there. The only reason I have it on my Discord channel is if someone joins the Discord server and asks for the advice, I can first give them like the basic advices which I have. And probably someday I will end up posting these on LinkedIn as well. Like for example, very recently Glenn Colling created a lot of, like Glenn Colling is a YouTuber who has more than 200K subscribers. He recently created a blog, Optimal Practice Strategy, a slide of Bitcoin. Like he also has a YouTube video here. So like you can check that video there. And like he is much stronger than me. So, like, and like he's around maximum is 2600, but the last contest was 2 years ago. His current level is around 2800 rated. Sir, why are you not working in top trading firms as they need high rated? I'd say it mostly because of like you wonder like you don't have time for to do anything else there. And, like I'm slightly fine with whatever comp I have and sometime. I don't have interest in development side. I only enjoy doing CP. Do you also not like development? Like, so like this is a tricky question. Like people end up asking development or computer programming, and my answer is why not both. And like I do like development, and like in day to day work I do. And when I was in college also, like I did had some open source project, not big one, but at least something which I can show people. Like for example, I created one this Discord board and remind. Currently, I'm writing it in Go. Now, like some of the work is in progress here. So it's a private repo, so no access here. So like I did had some non-zero project to show and some internships to show around, which I did when I was in first year. Like in third year, like COVID came in and I did not had any internship experience. But I did one internship in a startup for of my college alumni when I completed first year summers. Did you meet him at ICPC? Like I'm not sure who is him here, but at least I was in Amritapuri regional as a judge there. So like I did met few people over there. So that prison escape problem solvable using DFS? No, I don't think the constraints allow it to solve it using DFS. Like you will get end up getting it really. From where should start web dev? To be honest, I don't have an answer for it. The only experience I had was doing some internships there, learning some things there, and then trying to do the project idea, like basically Discord board idea, etc. I had. So like just Googled it and did everything there. So Colin, like no, like Colin lives in US and like he is participating in American regionals while I am in India and I never went to US. So we have definitely never met in real life. Like I definitely know he exists because he's a big YouTuber, has a video, etc. I'm not sure if he even knows who is Aryan. Sir, I am able to solve only 4 problems in YouTube. Please guide me what I can do to improve myself. Okay, yeah, like the basic terms I have is join the Discord server. Read the channel roadmap to read in 2 minutes, where I have some starting advices what people should do for the most of the frequent questions. And like if you are a beginner, like practice participating in ABC is no brainer. And what I did when I was less than expert, what I did when like I was when I was trying to reach masters, and yeah. So essentially, you can refer this first, and like this should be the preliminary guide. When are you going to post your summer? Like, I'm not grinding these days. Like, the only thing I do is participate in contests and share ideas, and nothing more than that. Like, I don't solve any problem outside contests for the time being. And like, I'm mostly fine with whatever rating I have right now, and probably to improve further, I would have to solve problems, but I don't have enough time for that. So like I am not in college, so I don't have a summer vacation to be honest. Like all 12 months are similar for me. I would be happy if you study about. Okay, like the Discord chat is there, but yeah. Okay, like during my summer grind, like like that was essentially the log I tried to maintain. Like I mostly like for most of the time, what I have done is participate in contests, try to solve problems that I could not solve, and if something new comes in, yeah, like I will probably look at it. Like there is some alert or something, and like that's the idea. Or like probably I can create a new invite. How to become expert in 3 months? Like I would say, like question should be how to become expert, and you should not attach a duration to it. Based on whatever background people have, like the duration to become something varies from a lot. Like for example, if someone has done math olympiad, etc., then the amount of time someone needs to become expert is really less. While if someone who has just started computer programming, the time required can be higher. Or if someone is in school, then like where they don't even know what binomial coefficient, etc., is, then they would need even higher time. How to become expert? The answer is already inserted in this channel roadmap to read in 2 minutes. What I did when I was expert or below, and in 3 months is something I would say like probably not a good idea to be there. What type of problem we have to do to become expert? Like again, the answer advice from Umnik, who is legendary grandmaster: get better X, do X. So if you want to become expert, the only way to do is look at the problems, solve which you cannot do it in contest, or look at the problem ratings over there and try to solve them. Okay, do you have some good topics to discuss in advanced discussion? I don't think I have some. It was mostly a clickbait channel, mostly inspired from Anand Oja server. Like Anand Oja also has a similar server, and nothing happens there. So like essentially, that's the idea. And yeah, like probably if a lot of people end up joining for that channel, then there might be something which people can discuss. Today you told a new topic 01 BFS, where to find this. Like the only way I found it when I found the first problem with US01 BFS. Like there are lists, but I don't advise going through a list over there. Like for example, like you know who recently created a huge list. Like it contains almost all the topics you want. Craft theory. Like he has divided 103 topics here, and like he had also added some ideas here as well. Or like in fact there is a code process catalog as well. It also contains a lot of good resources here. So you can find topics here, but I would say like that's not the best way to do problems here. Like for example, like there is one like the things I don't know, like Omnic posted, like he listed down a lot of topics which he doesn't know. And the only thing he says, if you know at least three of these things and you are not, you are doing it wrong. So like it's a bit of exaggeration, but the message is clear. Like the focus should be on trying to solve problems and learn the data structure which you need on the go. Stop learning useless algorithm. Go and solve some problems. Learn how to use binary search. So this often gets clickbaited as like you don't know how to solve binary search problem. That's the reason people are not or something like that. But mostly, yeah. And even like the you know who's blog, like it's the old problem where someone who's probably pupil says, "Thanks a lot this problem. I have made a resolution to complete this list in next few days." 7 to 8. And like Ericto, who was legendary grandmaster before and big YouTube, says that's a bad idea. There is a huge list and many of these are advanced. Practicing CP is about understanding algorithm and applying that also, not just about reading an article. It takes time. So like to be honest, I even don't know half of the algorithms probably in this list here. So this can probably be served as a reference when someone wants to learn something about a particular topic. Then they can refer the blog here, but not the other way around. Okay? Like go out all out on learning all the topics and then with the expectation you will improve. That's not how it works. How many time we have to spend for one problem depends on people to people again. If you see you are not making any progress, then it's better to sneak peek a bit on editorial, try to get the next in. The way I used to do it was like I used to take around 10 problems together, try to solve them in parallel. And then when I was done with 5 problems in that set, I used to add 5 more problems. And if after some time either I got you bored to some problem or if I was not making any progress, I used to pick one problem, try to take some hints for that problem or something there. And like that's better way rather than just staring at only one problem. So any more questions? Where I can learn maths for CP? Like probably the answer is same. From where you have learned DSA? Like for me, like you can probably just refer the same channel roadmap to read in 2 minutes. I have said like when I did CodeChef, what I did on code process, and I think I have answered that question. For beginners, code forces is a good problem. Again, I have answered it. For beginners, I strongly advise doing at code a beginner contest first. Then CodeChef starters and like then something you can do. Can you say resources for the standard problem? Depends on which standard problem you are asking. A lot of thing I would say standard. Like I say something as standard if I have seen at least 5 problems on that topic. But it's not necessary that everyone already knows about them. So like standard problem on DP, again the advice is same. Like I have mentioned it in my roadmap to read as well. Like you can look at sections here and try to find DP problems here. And like I have answered this question on the same channel, roadmap to read in 2 minutes. Like how to solve some standard or some frequently appearing problems on DP there. There are two resources I mentioned. One is USAV guide and the other one is CP handbook, competitive programming handbook. And like there are more books. CP competitive programming 4 recently came out. So like that's that too. And like CSCS problem set is good too. So any more questions or otherwise like I will call it a day. And like thanks everyone for joining in today. Make top 150 RNC problem set. I will do it someday, but probably not in the near future. So thanks everyone for joining.